Hello students, today we are going to learn about significant figures. First of all, what is significant figure? Generally, if we measure anything, the result of measurement should be reported in a way that indicates precision of the measurement. This result, what we have obtained from measuring the anything, generally having the result of measurement is a number that indicates all digits. Generally, result contains all digits. It is a number. Next, in this number, the reliable, all the numbers are reliable. Plus, the first digit is uncertain. So, in the result, we are having certain digits and uncertain digits. The uncertain digit is the first digit and the remaining all digits are certain. So, the significant figure means certain digit plus uncertain digit. Okay. Now, the significant figure means all reliable digits means a certain digit plus the first uncertain is equals to significant figures. Now, here if we take one example, suppose the school distance is 24.567 meters. Here the last digit 7 is called uncertain digit and the remaining 2, 4, 5, 6 are certain digits. Okay. So here the last digit 7 is always uncertain digit. The reliable digits means certain digits are 2, 4, 5, 6. 2, 4, 5, 6. Okay. So here the total how many digits? 1, 2, 3, 4 and the uncertain digit total 5. So number of significant figures here is 5. They are 2, 4, 5, 6, 7. One more example we will see. One more example 45.3 kgs. Here the last digit 3 is uncertain and the remaining digits are certain or reliable. So reliable or certain digits are 4, 5 and the uncertain digit is 3. So number of significant figures here is 3. Now we will discuss about rules for significant figures. Okay. All non-zero digits are significant. All non-zero digits. Here 4, 2, 6, 9, 4, 3, 2, 1. These are all non-zero digits. These are all significant. So here the significant figures total 1, 2, 3, 4, 5, 6, 7, 8. Number of significant figures is equal to 8 here. Okay. All non-zero digits are significant. Next, second rule. All zeros between non-zero digits are significant. Between numbers, here you say 4.092034. Here 0 is present here also and here also. These zeros are also considered for counting significant figures. So the all zeros between non-zero digits are significant. So here 1, 2, 3, 4, 5, 6, 7. So number of significant figures is equal to 7. Next, the terminal zeros without a decimal point are not significant. Previous example we are having decimal point. Here example there is no decimal point. So the last terminal zeros means the last zeros of the number. Terminal zeros without a decimal point. Without a decimal point. Here no decimal point is there here. So without a decimal, the terminal zeros without a decimal point are not significant. So here we does not take these three zeros while counting the significant figures. Here significant figures only two only. We consider only two numbers, that those are 4 comma 7. So the significant number of significant figures here is only two only. Okay, next, terminal zeros with a decimal point. Here without a decimal point, here with a decimal point are significant. Example 4.700. Here the last two zeros are also considered while counting the significant figures. So number of significant figures are 4. 1, 2, 3, 4. These two zeros are also considered while counting the significant figures. Here these zeros are not considered because here is no decimal, without a decimal. That's why these zeros are not considered for counting the significant figures. But here decimal point is there, so the last digits, terminal zeros, are also considered while counting the significant figures. Next, one more rule. For a number less than 1, means before decimal we get generally no number, means maybe 0, you can take 0. A number less than 1, zeros on right side of the decimal point but left of first non-zero digit are not significant. Here example, after seeing example once again we will discuss the rule. Here you see, here decimal point before 0 is present, means this number is less than 1. Now this number before 0, this 0 is not counted while counting the significant figures. The underlined 0, the underlined 0 is not significant. So here number of significant figures 1, 2, 3 only. Number of significant figures 3 only. So rule once again, see, for a number less than 0, zeros on right side of the decimal right side, numbers 0 on right side of the decimal but left of first non-zero left side 0 is not significant. So here number of significant figures only 3. One more example, you see, 0.002308. Here this number is less than 1 and these two zeros are before a number, so these two are not considered while counting the significant figures. But this 0 is considered while counting the significant figures. Here the significant figures, number of significant figures only 4. 1, 2, 3, 4. Significant figures 4 only. One more example, this number is also less than 1 because before decimal we are having nothing, means 0 is only present. So after a decimal this 0 is not considered for counting significant figures. So here significant figures 1, 2, 3, 4. 4 significant figures. Why these two zeros are considered? Because here decimal point is there. One here example, decimal after zeros, last zeros, means terminal zeros are considered. Without decimal no consider. Here decimal point is there, so that's why these two zeros are considered. That's why significant figures here, number of significant figures 4. Okay, next, one more example. Change of units does not change significant figures. Consider this example, 43.2 centimeters. Number of significant here is how many? 1, 2, 3. 3 significant figures. Centimeters, if you convert into meters, 0.432 meters. Here number of significant figures 1, 2, 3. 3 once again. This meters, if you convert into kilometers, 0.00042 kilometers. Here once again these three are not considered because this number is less than 1. That is why these three zeros are not considered while counting the significant figures. That is why here is also the significant figures, number of significant figures 1, 2, 3 only. Okay. So changing the unit does not change significant figures, but there is an ambiguity while changing the units. The ambiguity is here, you see, ambiguity in significant figures. What is that ambiguity? There is an ambiguity with the terminal zeros. Consider an example, 5.700 meters. Number of significant figures here is 4. So if you convert meters into centimeters multiplied by 100, so 570.0 centimeters. Here significant figures once again 4. Once again centimeters convert into millimeters, multiply by 10. So this decimal goes away. So 5,700 millimeters. Here there is no decimal. No decimal means we cannot consider these two zeros while counting the significant figures. So significant figures only here is only 2. But the rule we have discussed, change of units does not change significant figures. But here significant figures are changed. Means there is an ambiguity in significant figures. So to remove this ambiguity, this is an ambiguity because change in units does not change in significant figures. To remove this ambiguity, we have a scientific notation. To get rid of this ambiguity, we have a scientific notation. What is that scientific notation? If you see this, each number while changing units, you have to written it as a into 10 power b. This is the scientific notation while converting the units, where b is an integer, positive or negative, no problem. So positive or negative number, b is. So a is any real number is called significand. Now in this significant, for example, if you consider a significant example, 7.6 meters. Significant figures, number of significant figures 1, 2, 2. If you convert meters into kilometers, 7.6 into 10 power minus 3 kilometers. Once again, you are not able to, or not, you cannot consider this for counting the significant figures. Only a is a real number and this only significant. For this one only you have to take the significant figures. So no need to consider 10 power positive number or negative number while counting the significant figures. You can leave it. Only the significant figures are for a only, before number multiplied by this number only. 10 power minus or positive or negative number, you no need to take this number while counting the significant figures. So here the significant figures while considering 7.6 meters to 7.6 into 10 power minus 3, no need to take this number. So significant figures once again 2. 7.6 into 10 power plus 2, positive number, centimeters, no need to take this 10 powers. So significant figures 2. This is how by using this scientific method we get rid of this ambiguity in the while counting the significant figures. when we are changing a units. One more example, 4.700 meters. Here 4.700 into 10 power 2 centimeters. We have meters into centimeters. 4.700 into 10 power 3 millimeters. 4.700 into 10 power minus 3 kilometers. All examples, all numbers having significant figures 4 only. Like this, we can we can calculate the significant figures, number of significant figures. These are the rules while calculating the significant figures. Next, rule for arithmetic operations with the significant figures. In the next video we will see them. Thank you.